Okay, hello. So let's get on with the class. We're gonna start here. So we've already done reflections pretty much completely for our unit test. So here we're gonna start at refractions. So we already know, I think, from previous topics what refraction is. This ray diagram is a good representation of the type of refraction that we will learn to do here. So when refraction does occur between a ray, it occurs between two mediums. So this is passing from one medium to another medium. You'll see that the incident ray here, some of it is reflected while some of it is refracted. So the reflected part, we already know what to do. The angle of incidence is calculated with the normal, as you can see here with the dotted line, and it should be equal to the angle of reflection. Our concern is here, the angle of refraction. So angle of refraction does not depend on angle of incidence. Rather, it depends on something called the refractive index, which you can see is highlighted here. So it can be calculated using this formula where n, the refractive index, is equal to c by v. And c is the speed of light in a vacuum, and v is the speed of light in the medium itself. Which medium? This more refractive medium, the one where the refracted ray is actually going through. So that's how you do the refraction calculation. Here's some few refractive indexes already given for you. So you don't have to memorize this. Whenever you're doing some sort of calculation, they will give you the index of refraction or the refractive index to do said calculation. Now, Snell's law is basically a way that we use refractive indexes to get the refraction more accurately. So Snell's law কি বলছে? Snell's law বলছে যে when a light passes through two mediums and some sort of refraction takes place, right? Something like that. This is a very extreme example, but you get the point. Some sort of refraction takes place. So let's say this was air and this was glass. If you take angle I and angle R and make a ratio of their sign, it will give you a constant value, but only between air and glass. So if it was air and something else, let's say water, that would have a different constant. So that's where Snell's law came from. Here's the formula given again. So if we read through the topic a little bit, this relationship indicates that for any angle of incidence greater than 0, the ratio of sin I by sin R will be constant for any light ray that passes through the boundary between two medium. Media is plural. In fact, for any ray that passes from air into a second medium, refractive index n, Snell's law may just simply be written as this. So you see, refractive index n and Snell's law is very much related. As long as the first medium is air, the Snell's law constant and the index of refraction for the second medium are one and the same thing. So that's how you link refractive index and Snell's law. প্রথমটা যদি air হয়, তাহলে refractive index of the second substance or second medium and Snell's law constant same thing. আরো যদি আরেকটু explain করি আমি তোমাকে, if it is air on this side, একটা ray আসতেছে and there's a normal, এটা glass হইলে গ্লাসের যে রিফ্র্যাক্টিভ ইন্ডেক্স আর স্নেলস লর যে কনস্ট্যান্ট যদি আমরা বের করতাম ইউজিং দিস আই এন্ড আর, ওইটা একই জিনিস হতো। অলরাইট, so obviously here's a manipulation of the Snell's law formula. I think you can pretty much understand what's going on. So you had given a question to me and ওইটার প্র্যাকটিস প্রবলেমগুলো এই যে এখানে দেওয়া আছে and example 13.3 তে দেওয়া আছে. Unfortunately, diagram drawing for me will be very difficult in online because I can't make accurate lines. But I think if you look at the calculation, yellow light travels from a water into crown glass. The light rays are incident on the crown glass at an angle of eto. Okay? So water থেকে crown glass হয়ে যাচ্ছে. So let's call this water and this is sea glass. And its angle of incidence is 35 degree. and বলছে অ্যাঙ্গেল অফ রিফ্র্যাকশন বের করতে। সো রিফ্র্যাক্টিভ ইন্ডেক্স অফ ওয়াটার হচ্ছে 1.33 and refractive index of glass হচ্ছে 1.52। আমাদের কি বের করতে হবে? আমাদের এই যে এই theta 2 টা বের করতে হবে। if we call this 35 degree theta 1, theta 2 কিভাবে বের করব? so well n is equal to sin I by sin R, and you can see that this has also been distributed out in the previous formula we saw here. So they're using this formula where n is the refractive index. You'll see n1 is for glass, which is 1.33 sin 35 because that was the angle of incidence, and 1.52 is the refractive index, and you get 30 degree. So eighth angle type, if we were to draw, we would draw it accurately at 30 degrees. So you can use this example to find prism or math glove as well. Now we can also use Snell's law to kind of understand how speed is affected and other properties of a wave get affected due to refraction. If you look at this diagram is about wave fronts. I'm sorry, I'm still very sick. This diagram is about wave fronts. Now, it is going from vacuum to a more refractive medium, from 1.0 to something greater than 1.0. Alright? So you see that length or the space in between the wavefronts is lambda 1. And lambda, as we know, is the wavelength. Right? So এটা হচ্ছে wavelength. But যখন refraction হইলো, wavelength আরো ছোট হয়ে যাচ্ছে. You see? The distance between them has decreased. Why is that? Because lambda jeta depends on the speed of the wavefronts. So speed ta change হয়ে যাচ্ছে. So wavelength v equal to কি f lambda, and আমরা lambda নিয়ে concerned, so lambda is equal to v by f, where v is the speed, right? So একটাতে যদি higher speed থাকে তখন lambda higher হবে, and যেখানে v কম হবে or the speed কম হবে ওখানে lambda ছোট হবে, and remember frequency must stay constant. Alright? So here is what I just said. The wavefront travels faster in air than they do in water. It follows that v1 is greater than v2 and lambda 1 is greater than lambda 2. Okay. এইখান থেকে তোমাকে কিছু calculations আসতে পারে. So here's how you do those calculations. This is less dense material, this is more dense material. So less dense material আমাদের এখানে একটা ফর্মুলাটা জাস্ট এই ডেরিভেশনটা নট সুপার ইম্পর্টেন্ট, তোমার ইম্পর্টেন্ট পার্টটা হচ্ছে এই পার্টটা where sin theta 1 by sin theta 2 is lambda 1 by lambda 2, where sin theta 1 is this angle you see here and theta 2 is this angle you see here. So পরীক্ষার মাঝখানে কনফিউশনটা কোথায় হয় is when you do draw an incident ray and it a refracted ray. Oh, let me redraw that too. And it a refracted ray and you draw wavelengths coming in and refraction টা হয় theta 1 টা আমরা অনেক সময় এই অ্যাঙ্গেলটা নিয়ে নেই, এটা না, see এই অ্যাঙ্গেলটা, alright, and theta 2 টাও এখান থেকে এসে it goes like this, এই অ্যাঙ্গেলটা, okay, the angle created here, this is theta 2, which is much better shown in this diagram. Let me just erase all of this. So make sure theta 1 and theta 2 টা তুমি বুঝতেছো. But here you can also see যে এইটাও কিন্তু theta 1, এটাও কিন্তু theta 2. So consistency রাখবা, ঠিক আছে? theta 1 কোথায়, theta 2 কোথায়. There we go. And you can use this to expand it. কিভাবে expand করবা? আমরা lambda 1 lambda 2 দিয়েছি, and we can use v equal to f lambda to find v1f and v2f. f and f কেটে যায়, v1 v2 রয়ে যায়, and so we can apply Snell's law in multiple different ways as long as we know these angles to be v1 v2 lambda 1 lambda 2 n1 n2. Alright, so এটাই হচ্ছে refraction এর part. So there's a few math that you can practice here. This is experimentation, it's not super important. Okay, total internal refraction. Now, total internal reflection কখন হয়? If you go back to the original diagram we saw that when it crosses over, like an incident ray crosses over, some of it is reflected, some of it is refracted, right? That's what we saw. There is a certain angle that happens when এই যে এই রিফ্র্যাকশনটা হইতে হইতে you see রিফ্র্যাকশনটা হইতে 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 আর বের হতে পারে না, it just gets completely reflected in the medium. এই যে ওয়াটার থেকে বেরই হয় নাই, ওয়াটারের মধ্যেই চলে আসছে. This is known as total internal reflection. Whenever এটা হয় তখন আর রিফ্র্যাকশন হয় না, ইন্টারনাল রিফ্লেকশন হয়. ওকে, এখান থেকে আরেকটা কনসেপ্ট জানতে হবে তোমার, which is critical angle. What is critical angle? Let's find out. So এটা 30 থাকলে এখানে একটা 42 ডিগ্রি অ্যাঙ্গেল হচ্ছে, এটা 40 হইলে এখানে একটা 59 ডিগ্রি. So you see this theta is getting smaller and smaller. এই দুইটার মাঝখানে একটা রে যদি আমরা ড্র করি somewhere in between these, হ্যাঁ, where this theta আর কি, এই থেটাটা becomes zero and basically the ray skims along the boundary of the two mediums. When this happens, this is known as critical angle. Critical angle এর চেয়ে একটু বেশি হয়ে গেলেই total internal reflection হয়. That is known as critical angle. Here is the definition. For any two media, the size of the incident angle for which the angle of refraction is 90 degree. Basically দুইটা যদি মিডিয়া থাকে and একটা incident ray এমন যেখানে রিফ্র্যাকশনটা হচ্ছে, let me draw it with a different color so better বুঝতে পারবা. এই যে ইনসিডেন্ট, রাইট, and refracted অ্যাঙ্গেলটা হচ্ছে 90 ডিগ্রি. 90 ডিগ্রি হইলে কি, it's on the surface. ওকে, এই যে এটা হচ্ছে 90 ডিগ্রি. That is critical angle and total internal reflection. What is one common use of total internal reflection? It is optical fiber. And diamond-এও হয় অনেক total internal reflection. Okay, now let's look at an angle. I mean an example. Alright, বলছে what is the critical angle for the quartz glass interface? Quartz glass and air, মানে একটাতে হচ্ছে Q glass আর এক সাইডে হচ্ছে air, that's what they mean. Angle of refraction at the critical angle is defined to be theta r is 90 degree. Refracted rate 90 degree হবে. So critical angle টা বের করতে হবে. What we need is refractive index of air and refractive index of quartz glass. So we will use this formula again, where আমাদের sin theta critical টা বের করতে হবে, n2 এর যে sin theta ওইটা বের করতে হবে. So theta টা আমরা জানি না এখনো, theta and আর n1 এর সাথে যে sin theta টা ওইটা আমরা জানি 90 ডিগ্রি মাস্ট, বিকজ রিফ্র্যাক্টেড যেটা বেসিক্যালি কোয়ার্টজ থেকে গ্লাসে যখন যাবে এটা যদি হয়, এইটা মাস্ট বি, ও সরি, এই যে রিফ্র্যাক্টেড রেটা মাস্ট বি হোয়াট 90, I can draw straight lines কেন জানি আজকে, আচ্ছা whatever. রিফ্লেক্টেড রেটা এখানে একটা রিফ্র্যাক্টেড রে থাকবে at 90 ডিগ্রি and this can be some theta, and আমরা এই থেটাটাই বের করতেছি. We plug in the values as normal and we get our answer 42.9. This is the use cases. There's also some other uses that you can read upon. And that is basically all about refraction. I'm going to break these videos down into subtopics so that it's a bit easier for you. So refraction ta ami ekhane rekhe dilam, and next we'll learn about prism and lenses.